fairly regularly, you're going to see basically you'll know by looking at the cutter if it's going too fast or too slow. If you go too fast, remember you're going to hear that squealing sound. It's going to start to burn perhaps and be dull and chip because it's going to overheat. If it's too slow, you're going to get a bad finish. Okay, so speed's important. So we would calculate that. Remember that is the 4CS over D. It's typically increased for soft materials and decreased for harder or abrasive materials. So here's our formula. Now this is two slides on a page. You guys can see this okay? Everybody can read it all right? Yeah?
Yep, that's up.
Okay, so calculating the spindle speed, which is your RPM, is the cutting speed of the material times 4 divided by the cutter diameter for the milling machine. And again, if that's the lathe, it's the workpiece that's turning. So one of the things you have to remember for the test, it would be 4 CS over D, 4 times the cutting speed over the diameter of whatever it is. In the milling machine, of course, it's the cutter. So, there's Will. He looks like he got in. He was having difficulties. Welcome, Will. Hopefully he's connected. So we're looking at cutting speed, 4 CS over D, a good one to remember. Once you know the cutting speed, and feed rate is in the case of us, like as millwrights, we're typically hand feeding everything. We're going to know by the feel, and you're already seeing that with your parts as you're milling across. You can tell if your cutter's dull, if your cutter is running too fast by the noise it's making, and how hard it is to push the cutter through the material. If you get a lot of resistance and your locks of your table aren't on, that's because your cutter's dulling up, and you're going to start seeing heat develop and stuff like that. A little bit of smoke will start rising, as you're going. But the feed rate, if you were to calculate it, so you need to know exactly how fast you can feed this cutter into your workpiece, is simply by taking the number of teeth that's on the cutter, how many thousandths of an inch of material each one of those teeth will take, and then how fast is it spinning. So if you think of feed rate, just think of multiplying everything. So you have the RPM of the cutter. How fast is it turning? If there's 10 teeth and it's a 10-inch cutter, and each chip can take 10 thou, we can multiply that all together, and we can figure out, and if you visualize it in your head, as that chip goes around the cutter and takes off its optimum amount, say 10 thou, just for an easy times table. So each tooth will take 10 thou as it goes around. So if there's one tooth and it's going at 10 RPM every minute, it's taking 10 thous of a cut, 100 thou. But if we have 10 teeth, it goes 10 times as fast. So just think of feed rate as multiplying the speed and the teeth and the chip load per tooth all together. And it kind of makes sense when you picture it in your head that you want to know how much that you're like scooping off that material, like taking away. So if we give you the RPM, the number of teeth, and the chip load, you'll be able to take that, multiply it together, and figure out your feed rate. And remember, your feed rate is going to be in either feet per minute, inches per minute, or meters per minute. Typically, feet per minute is what we do it into. So we can see here in this example, we'll use a end mill. We're just in free machining steel. So we're going to go with an end mill. And we're going to go in thousandths because I can work in thousandths a lot easier than metric. So we're looking at 6 thousandths per tooth. If it's a 4-flute cutter, then that's 4 times 6 thousandths. So we get a total of 24 thousandths of an inch per revolution. And if we're running that at, say, 800 RPM, we're taking off 19.2. That should be inches per minute. So that's what we're taking off as our feed rate. So that's one to remember. The depth of cut, if you want to do by the rule of thumb, it's half the diameter of the cutter. So if you have a 1/2 inch cutter, your maximum depth should be 1/4 of an inch. You could probably do more, but you won't be able to run the full feed rate. So, and of course, it depends how good your machine is, how much horsepower you have as well. So that's on the depth of cut. So rule of thumb, half the cutter diameter. Cutter types, we know different cutter types. We looked at those. Most cutters, the 4CS/D, of course, is for high-speed steel cutters. That formula works with the high speed, not the carbides. You go 2 to 3 times faster with carbide. Always good to remember. Types of cutters. We had these questions in our review. You know, the types of cutters: stagger tooth, side and face. We have the high helix one that we looked at, and just a plain cutter. You can see how the helix of the cutter is a lot higher here than it is here on the light duty, where it goes flat across. And you, of course, have gear cutters, slitting saws. Remember the slitting saws? They're the real delicate ones. You read about that in the Machine Tools book. It talks about those being easily broken. More cutters here. We've looked at some of them. You guys are either choosing a 2 or a 4 flute end mill. They're single-ended, the ones that you're using. I prefer those over the double-ended. I find the double-ended stick out too far and give you more chatter, less good a finish. This is less rigid because it's sticking out if you don't have the right holders. Like the R8s aren't the right holders for those. Another type of cutter we didn't look at too closely, and we will next semester, is the Woodruff key seat cutter. This is for putting in those Woodruff keys like this, these half-round keys. It's a different type of key. We're going to take this next semester, but I want you to notice here